Hey, welcome back to the FTC Student's Guide to Autodesk Inventor with Nick from Hazmat Biohazards. This is episode 6, mostly part making. So, last episode we looked at turning sketches into features and how we can make different sorts of shapes using sketches. Now I want to give you a better picture of the workflow for actually working in your robot assembly and some of the tools that are going to help you create parts off of other parts. So I'm going to start working and I'll show you what I mean. Let's get a couple parts here. Let's grab 2 channels. And if I constrain them with some flush constraints here and move them apart a little bit. All right, let's say you've got these 2 towers or something and you want to put a panel that goes across the back of them. If I press this create button, which basically lets me make a new part inside of an assembly, and this part is going to become our panel. Now, if you don't know about this little tool called project geometry, which I'm going to show you in just a second, you'd have a really hard time making a sketch with holes that just touched a line over the holes of the channel. Luckily, we can make this part pretty easily, and this becomes a relative part making because we're taking geometric information from another part. So you can think of it like we're really building a part off of another part. I'm gonna make a sketch on the back of our channels here, and instead of drawing our circles for holes myself, here you can see the project geometry tool, and this thing really is like a magic wand. If you take it and you hover over a blank spot on the face of this channel and click, you see all these yellow lines, which are sketch lines. So you just made a sketch off of the whole back of the channel. Now with these lines, you can't manipulate them at all because they're defined elsewhere. So you can't move them or change their measurements because those are defined by the go build part itself here. Now I'm gonna undo that because I don't really want the whole sketch. I just want a few different holes. So if I take project geometry and select certain circles instead of the whole face, then I can get some great reference information. I need to throw in a rectangle here. And if I extrude this sketch, then hey, here's the part. Then I can chamfer the corners a little bit to make it cleaner, and there you go. It's done. You can very easily then CNC machine this bracket out of 1/4-inch plastic and take some bolts and attach it to these channels. There you go. Now a few little pro tips for cleaning up your assembly. As you can see, the sketch plane is still visible, and it's kind of ugly and kind of cluttered up your screen if you have a lot of them. So if you right click on it, you can make it invisible. If you look at the part on the sidebar, you can see this little icon here, which is telling us this part is adaptive, and I'll show you what that means. If I constrain these 2 channels together, you see that our bracket actually changes pretty dynamically as well, which can be useful sometimes, but more often just ends up changing your assembly by a little bit accidentally. Definitely from all of my experience, whenever I get a CAD error, there's like an 80% chance that setting a part as non-adaptive fixes it. So I would highly recommend just getting into the habit of setting all of your parts as non-adaptive as soon as you make them. Getting in that habit is definitely going to help you in the long run. If we set this part as non-adaptive and move it, you see that it's no longer constrained to the channels by the sketch. It's constrained to the sketch plane. Basically on the back of these channels, but if you wanted to delete that, you could. So we can reattach it with some axes constraints, and hey, so now we have our part made and part of our assembly, and we did it all pretty fast. You know, we didn't have to go and really design our own crazy sketches. We just took the information that was right in front of us and reused it, extruded it, chamfered it a little bit, played with the constraints a little bit, made it non-adaptive, and boom, you're done. And project geometry isn't just between 2 parts. You can take geometry from really anywhere. So if I make a part and make a sketch in a little box, and I want to put a hole here in the side, I can really easily come to the other side and make a sketch and project the geometry of that hole so I can mirror it really easily. So the last thing about part making is in an assembly, I'm going to grab some extrusion here, is that we can actually edit parts. So even the ones that you don't make, even if you import it from the CAD library, you can still change it quite a bit. So a really common edit that I've done countless times last season was cutting extrusion to custom length. So if I edit this part, this extrusion piece here, I make a sketch on the end and I make a cut extrusion, I can cut this extrusion down basically to whatever length I want. And you can do this with any part in CAD, so don't be afraid to edit parts that you didn't make. Just be careful as you might need to re-import a new version if you want to use that whole length extrusion again. So say I have this certain length of extrusion and I import that step file to an IPT. That IPT can only have one version. So if I have a 12-inch extrusion thing and I cut it down to 10 inches, if I try to re-import that same part, it's just going to come in as 10 inches again, because Inventor will save the edit that you made to the part. So if you wanted to get another 12-inch extrusion, you'd have to re-import the step file again with a different name, which is really important because that can be frustrating too, is if you open a part and that's like, wait, this is the edited version, I want the new unedited version, right? Definitely whenever you re-import a step file, it creates a new version, so if you just change the name of the .ipt file that it becomes, then importing a new .step file won't be fine. So I think that's all I really have for part making. I mean, now using the sketches and the project geometry tool, you can make really complex faces and extrude them to make parts, and you know how to constrain parts together in assemblies. So at this point, really, honestly, if you use all of the tools, or at least you can figure out how to use all of your tools as you kind of work, you can basically design anything you want to. This also kind of marks the end of the design lessons with CAD because there's not much more to teach you. It's really not that hard once you get to know how things work, but it does take some practice before you can really understand it. So if you don't really remember what some tools do, or if you forget where the button is, don't worry too much about it. Just come back and rewatch these videos, and Nick from the past is going to show you how to use all of them again. That's kind of the point, like I said in the first episode, is like if I cover everything and I sort of have like a little segment for each tool, then like it's like, oh shoot, I forgot how to do a loft. Then you can come back to the part making episode and find where I talk about the loft. And like, boom, there you go. Now you can refresh yourself on a little bit of information, So having covered all we have, I would really just encourage you to try to make something. Maybe if it's a drivetrain or a mechanism or really anything, I would encourage you to pick a project. Say, I want to make this thing. And just CAD it. You can add different parts of the assembly from the library, of course. You can add the constraints. You know how to do all that. You toss in your own parts. If you're like, oh, what if I did like an intake like this? And you can make your own custom drivetrain panels. It's a really common custom part. Electronics mounts too. Like say you want to have like a little phone case. Those are pretty common electronics mounts. Anything, man. Whatever you feel inspired to make. It doesn't have to be a whole robot, but make something. And the next episode, we're gonna take whatever you made and we're gonna make it look really pretty and make some really cool renders of it. Which is a really good way to show off your designs to other people. Congratulations once again for sticking with it. If you made it this far in the series, I'm going to see you next episode for some rendering. Bye. Hello, welcome to the post-credits. I actually thought of an idea and set something up this time before I started recording. How about that? So here we've got a big old stock of 1/2-inch Thunder Hex and a classy 6mm Tetrix D shaft axle. And what I'm going to do is I'm going to try to make a shaft adapter that will cause these two to rotate together, like a weird coupler thing. All right, let's start by creating our part. Select the face. That's the right plane. Let's project some geometry. So right off the bat, we got some pretty cool stuff to start working with here. We've got an outline of the Thunder Hex shaft here and an outline of the D shaft as well. And both of these are going to be pretty important. So let's start with the D shaft. How about let's make a circle that's bigger than it. All right, and we're going to extrude this profile up the D shaft a little bit. Yeah, an inch actually sounds pretty good. So boom, already just by projecting the geometry of the outline at the end of it, we've now got this really sick little gripping casing thing here. That's pretty cool. Now we're gonna do the same thing again with this part. I guess I need to project the geometry again of that, don't I? Make a bigger outside thing. Project geometry. Oops, I'm sorry. Not that. We want to do extrude. Going to extrude the outer section of this part here. And we're going to do it in the other direction. Okay. Sweet. So yeah, check that out. We're getting pretty close already. This is going pretty quick. So what I'm going to do now is just to give ourselves a little bit of overlap, because right now this is right on the end, right? I'm going to project the geometry of this outer circle and extrude this part just by a little bit. Nice, now I've got a good little cross section. We can give it a loft so it is extra strong. Boom. Now I've got a cool little shaft coupler. So let's do one more step. Let's say you want to be able to put a set screw in here. Now, I wouldn't recommend actually doing this because if you're going to make this part, you'd have to 3D print it, and 3D printing, putting screws directly into 3D printed threads, unless it's 100% infill, generally not the best idea. But let's do it. We're going to start with a sketch on the bottom of that. Oops. put a 3mm circle there. So I've got a great little hole going into the channel there. We'll stick the same thing on the other side. Cool. So now you could put your M3 bolts into here. You could thread into this plastic, and it would help you grip each of these two shafts. So maybe a little bit of a finishing touch, as always. It's probably going to be too big. Let's give us a smaller fillet here. That's perfect. You can do this on both. Apply. And yeah, I mean, check this out. We've got this great little shaft coupler here, which you now could turn this big beam, and it would turn the, or I'm sorry, this big axle, it would turn the smaller axle right along with it. So yeah, fun little thing to whip up and do. Pretty good example of the project geometry tool in action, and making a part within an assembly as well. So yeah, I mean, you could 3D print this if you wanted to, and now you've got up another part that you can add to your robot. So pretty cool. Yeah, so I think that's all I'm gonna do for now on the part making. I think I did some pretty good examples in the videos that covered a lot of the great stuff. So yeah, I'll see you next video for those of you that stuck it out this far, for some rendering stuff, and that's gonna be the last one. So you're almost there. Keep going. I'll see you in the next one. Bye.